Hello all, hi, this is Sriranga Kulkarni. I'm a technology professional working in software engineering field. Thank you NES BACT team for allowing me to share my idea or overview on knowledge discovery, data mining methodologies, especially CRISP methodology. For any queries or any details, you can contact me at my email ID provided here, and also connect me at my LinkedIn profile. Yeah, let's start then. So here's the agenda. Today we are going to go through knowledge discovery, the overview, and also data mining. Where does the data mining falls in the knowledge discovery process, and the CRISP DM methodology and its stages, this process phases, and then some question answers if we time permits, and then also we'll see the next sessions that's lined up. So we keep hearing about the terms machine learning, statistics, databases, visualization, data mining, data science. Actually, all these are interrelated fields. All these are driven by the data and then the algorithms. So data acts as a basic point where all these techniques, tools can be applied on to infer or to achieve our target of the data analytics projects. So data mining and knowledge discovery is one of the important components, as you can, or important techniques or process of the data science methodologies. So we are looking at this aspect of data science today. We will see different details about machine learning and visualization in the upcoming sessions. So yeah, let's start with the data mining and knowledge discovery. So what is knowledge discovery? So knowledge discovery, as per Advances in Knowledge Discovery and Data Mining textbook mentioned below, is a process of identifying valid, novel, and potentially useful, understandable patterns in the data or the input data. So in knowledge discovery, we are trying to infer some results, patterns from raw input data from various sources. So the data can be from social media, from the transactional data, from web portal, manual, data entry, point of sale applications, CRM applications, BPM, business process management applications, from wherever. Multiple sources of data can be combined and stored, and then we can infer different patterns from that data which are very business useful to the business goals. So that inferences or understanding of the processed data, we call it as knowledge discovery. This whole we call it as knowledge, and the whole process of arriving at actionable items or inferences or results from raw data is known as knowledge discovery. So this diagram depicts an overview of knowledge discovery steps. So we start with IT systems, where majority we collect data. Actually, data collection happens from the IT system, and then the transactional data, the social media data, the unstructured and the different structured data. All the data can be transformed into a standard format called as data warehouse. So once we have data in the data warehouse, next step is to define business goals or the knowledge inferences we want to make, and then select and clean that data and then store it in a subset of the data warehouse, maybe called as data lake, for example. Once this data is stored in the database or data lake, then we need to transform it, which we may call as transform data, which may be further used by data mining. So as you can see, data mining falls right in between the knowledge discovery process. So once we apply data mining techniques, the steps involved in data mining, we can see or infer different patterns and rules emerging from the data. So then after we arrive at certain patterns, rules, inferences, then we need to evaluate whether we are at the right track or whether we are expecting the same or whether these are aligned to the business goals. So then once we are okay, then we need to store those inferences and rules in a format. We usually call it as knowledge representation. So these knowledge representation actually contain, it can be simple yes or no action item for a specific behavior. Suppose if we are handling the or we are doing a knowledge discovery on oil and gas manufacturing units, suppose, then the oil and gas manufacturing IT systems capture the sensor data, and then after the collection, transformation, and applying data mining techniques, we come at a conclusion that sensor ABC or group of sensors ABC cluster may not work after 15 days. Then the knowledge representation would be ABC sensor, action to be taken, servicing or checking or root cause analysis of the sensors. So this actionable result goes into the integration, or it will be integrated with the main IT system again in the form of visualization or in the form of API or a rule-based engine. So integration may happen in many ways. So that's why it's very important to represent the results of data mining in a knowledge representation. And then the human users can easily interpret the knowledge representation. So if we want to make use of knowledge representation by a system, then we integrate the data, that is a knowledge represented data format, to be used by IT systems either in the form of dashboards, visualizations, or rule-based engines, etc. Or if we want to further analyze this representation or interpret the results from the patterns and rules we got it from data mining, then we can do human analysis. So yeah, this diagram represents roughly the overview steps that involved in the knowledge discovery. Okay, then once we know the steps, we have seen here data warehouse and featured data, right? Actually, this data is represented in OLAP format. We call it online analytical processing. Okay, there's a mistake here. It should be online analytical processing. Okay, so actually this online analytical processing data, right, it is different from the transactional data. Suppose if there is an insurance company, it is collecting the data from new business users and then applying for the proposal, then converting them into insurance policies. That data is called as online transactional data. So that is the operations data that is required for end-to-day. Actually, it records the end-to-day operations of an insurance company. Suppose we want to analyze that data, then we, instead of disturbing the online transaction data, we go for online analytical data that is represented in data warehouses. So online analytical processing data is intended to provide multi-dimensional views of the data. We call it data cube. For example, the MS Excel pivot tables are the basic form of OLAP tools example. So for a sample OLAP cube, data cube, we can see an example as follows. So here, this cube, the green color cube you see, is a representation of the products, the day which has been sold, and also the city which has been sold. So this is a representation of product, city, and the day. So all three together form a cube. So for example, we can see here number 56 actually represents the number of units sold of the product category bread in the city LA. You can see here 56 represents on Monday there are 56 units of bread sold in the city of LA. Likewise, different cities can be represented by z-axis, roll up to religion, and category is the product, actually product category, which forms the y-axis, and the day of the month or day of the week rather forms the x-axis. So this is a typical cube. where OLAP data is represented in which format. This is just an example. It can be any table, any of the data. Once we have all the data prepared like this, then we need to apply data mining techniques. As you can see in the step 3, data mining, transformation and data mining. Actually, these are iterative process. I'll come to this point in a while. These are intermediate processes, iterative processes. So once we have the data in the form of OLAP cube data, then we can move to data mining process. So data mining, actually data mining is a subset of knowledge discovery process where we try to clean the data and then apply modeling techniques and then evaluate our models and study any hidden patterns that we are able to achieve or gain through data mining methodologies. So there are various industry standards or various methodologies available for the analytics data mining process, like my own SEMA, KDD process, or any domain specific processes. But among all of this, one stands out across domains, that is CRISP-DM. CRISP-DM is cross-industry standard process for data mining. CRISP-DM is the most popular data mining strategy or process that is adopted or methodology that is adopted or used for multiple analytics projects in the industry. It has been around since 1996 and was first developed by IBM and later adopted by the industry. And IBM was introduced this methodology as part of their SPSS software package. This CRISP-DM actually provides a standardization approach which makes it best suitable for applying data analytics projects or data mining projects. So as you can see from the poll, almost 50%, close to 50% of the population or of the poll results prefer CRISP-DM methodology over other methods. So CRISP-DM again stands for cross-industry standard process for data mining. So now in the next few slides we are going to see the various stages processes involved in CRISP-DM. Okay. So this diagram, very popular diagram, represents overall or overview or high level stages of CRISP-DM. So we can see here it starts with business understanding and then goes on to data understanding. And we can see here these are iterative processes, meaning if you bi-directional arrows actually signify that the process is not sequential, may not be necessarily sequential. In some of the complex projects, we can go back to the previous step and then re-strategize and again come back to the next process or next step. So business understanding, data preparation, modeling, evaluation, and deployment are the 6 major steps involved in CRISP-DM. You can see data is center of all these 6 steps. Actually, this picture represents that data is a major contributor or underlying factor around which these 6 stages or processes are revolving around. So yeah, then go to business understanding. Okay, before that, this is a circular overview diagram. So next diagram, this diagram shows that this is from the CRISP-DM website. This is a visual guide to the CRISP-DM methodology actually. So as you can see here in this diagram also the importance of iterative process, that is the arrows which are going back to the previous stages. For example, here the data understanding process actually going back to the business understanding just signifies the importance of iterative process in CRISP-DM. So that whenever we find that certain things are not going according to the plan or certain results are not as expected or not aligned to the previous stages or not aligned to the business understanding, then we can always go back and then study and then change the data or transform the data accordingly and come back again to the next process. So it is iterative process. It is an important step actually because it's you can see multiple stages actually interact back to the previous steps in this data mining life cycle. So business understanding, we actually identify the project objectives, like what exactly is the necessity for this data mining project, the background, the business objectives, the business success criteria, and then what are the available inventory of resources and requirements, constraints and assumptions, and what are the risks and contingency plans, the terminologies, the cost and benefits required for to run this project, and the goals, the data mining goals, which are the techniques we may go ahead with, or data mining success criteria, and then coming up with a project plan. All this is part of business understanding actually. Once we are okay with business understanding, then we can go with data understanding, which really deals with collection and reviewing of data, which is a major step actually. When data understanding is done, then we go with the data preparation, because the data that we collect from various resources will not be in a standard format that can be applied, where data mining modeling can be applied. So we need to transform the data which is suitable for modeling techniques to take over. So for that, all those processes is involved, or all the activities will be involved in data preparation, so that we can select and cleanse the data, derive some attributes, and then merge the data and then reform the data which is suitable for the next stage called modeling. So once we are at the modeling stage, then we can apply different modeling techniques, and then results can be published. And then if the results are not that great, or we want to see some other kind of and we understand that we may have to apply different modeling techniques apart from the current ones, then again we can go back to the data preparation stage, and then come back to again for modeling. So once we are happy with the modeling results, then we can evaluate the model and draw conclusions. Suppose and then we can compare these conclusions with the business goals. And then once we are happy, then we can go to deployment stage, where we actually deploy the models developed in production environment, and then the system is used by the end users. So this is the visual guide to CRISP-DM methodology. So we'll go in depth on each of the stages, and the activities that we can define in each of the stages in the next few slides. So first up is business understanding. So main important aspect of business understanding is we need to set the objectives for this data mining project, and in terms of business goals. Suppose for example, we need to find the number of people or customer segment that we can sell a product to. Suppose a company is launching a new product, then we want to understand the market where this product advertisement can be targeted to. Then the business objective may be identify the customer target segment. For this, the newly to be launched product is intended for or to be marketed at. So this can be a business objective. Then we can discuss. Then we can determine the business success criteria by adding some percentage, like 50% of the products can be sold to the different targeted customer, those kind of business success criteria. And then we can assess the current situation, like where are we, what are the resources available for running this project, including the requirements, assumptions, constraints involved in the project, the risks and the contingency plans that may be required in case we might find some problem or may stuck at some point. And then all the glossary of business and data mining terminologies need to be designed and reported, and because this will be acting as a reference point to be used by multiple stakeholders involved in this project. And then we need to also construct a cost benefit analysis for the project, which compares the cost of the project with the potential benefits to the business if it is successful. And then during this process we may also come up with some business and data mining goals, and also the overall project plan. So all these activities listed are part of business understanding. So once we are okay with the business understanding and we are convinced that this project is going to get some benefits or value addition, then we can go with the data understanding process. That is the second step from this data understanding process. So data understanding involves data loading and producing initial data collection report. Suppose a marketing department of a company can analyze that what are the various source points of the data that being collected: the main transaction data, the customer relationship management system data, the BPM data, business process management system data, uh, the cross-sell upsell management data, and the social media data, the reviews and feedback portal data, etc. So once we have the data, then we can describe the data and produce the data description report, which includes its format, quantity, for example, number of records and fields in each of the tables in a database, the identities of the fields, and any other surface features which have been discovered. So, so these help us to evaluate whether the data acquired satisfied the requirements or not. Suppose if we take the examples discussed previously about targeting a customer segment for a newly launching product, then it becomes very important to analyze the data, capture the data which is related to the customer segment. And then once we analyze the customer data, then it becomes helpful to whether the customer data acquired satisfies the requirements or not. So once we have gathered the data, we need to explore the data. So exploring the data by using querying such as SQL querying and manual Excel querying of data, data visualization, and reporting techniques such as the distribution of key attributes, relationship between pairs or small number of attributes, results of simple aggregations using SQL, and then properties of significant subpopulations. Suppose we are analyzing the target customer data again, then we can first analyze demographic data of a certain region or certain age or certain gender of customer data. Those form the subpopulations actually. So this kind of data exploring is very important to better understand the data. So once we are okay with the exploring data, the results of the exploring data by various means, then we can document this as part of the data exploration report. Once the data is explored, then we can verify the data quality and examine the data quality such as data completeness, data correctness, number of errors it is processing, and if any values are missing, what are the means we are trying to achieve to handle the missing values, etc. And all these steps taken should be reported in the data quality report. And then once we are done with the data acquired report, data exploration report, and data quality report, then we need to list down the results of the data quality verification. So if suppose if quality problem exists, then suggest possible solutions. That is why we can see the data understanding is always we can go back to business understanding. It's a iterative process. So next step is after data understanding, data preparation. This is the third step. Usually data preparation is a major task, although I say 90%, it may vary 60%, 70% of the overall project. So actually data preparation, actually what it involves is, it involves collection of the data from multiple sources, assessing the data, and whatever data understanding reports we have, examining those, and then trying to come up or derive new data. Like suppose if we have gender in one of the or age, then the age is an absolute value, age of a customer. So we may come up with a range of values. So like demographic age group, like 20 to 25, 25 to 30, 30 to 50, these kind of different ranges. So these are all data transformation. We are creating new variables. So this data preparation actually iteratively involves multiple activities. So I will list down the activities here. I have tried to list down that data preparation activities include cleaning of the data that must be kept at every step in order to operate within the constraint of the project. And we need to record the technical constraint and other factors determining the data, which also must be pinned down to eliminate the bias and derive insights more easily. Actually, eliminating the bias is very important uh, for models to work in the future stages. Then we need to select the data to be used for analysis. Technical constraints such as limits on the data volume or data types may be taken care of. Meaning if you are collecting a survey report, suppose some of the survey report answers may not be religiously answered or honestly answered. So we need to analyze this data and then we need to address these limitations as well. So the data selection covers selection of attributes, columns, as well as selection of records, rows in a table. Then we need to construct the required data, then integrate data from multiple databases, tables or records, create or come up with new records. And then we need to merge the table, like example, the data may be across multiple systems like business process management system also has customer data and customer department also has customer data. So we may need to merge these two to come up with a single source of information. And also we may have to come up with aggregations such as number of sales of a product for a particular demography. All these kind of SQL operations can also be done in the data preparation for summarizing or getting the derived in the form of data transformation. So once this data preparation is done, and then if we can go back and relate this as a third step in the data preparation is complete. But if you go back to our original diagram of knowledge discovery, we are here in data transformation part. So data preparation, data mining comes under data transformation part. We are in the middle of the knowledge discovery. Then comes the modeling part. Actually, this is where the data scientists come into picture, who knows multiple modeling techniques that are there. So selection of modeling techniques is dependent on the data mining objective actually. Suppose if you want to build a classifier, suppose whether a mail is spam email or not, then we can use decision trees. But if you want to target a segmented customer for marketing for a soon to be launched product, then we can use clustering technique. So these are different objectives. Supervised and unsupervised models. Supervised models include, we already know the result we want to achieve. So we are trying to align or explore the data and then come up with the results. Usually classification of mail into spam or a valid email is usually a supervised learning example. Unsupervised learning is we don't know the result of the algorithm that we are trying to apply. So we will apply first the algorithms to the data set available and then see the results if any new insights or patterns that we observe. The classic example is for this is coming up with a group of books in a library. So labeling of data will be results actually. So we may actually this can come into classic example of technical books, non-technical books. But we allow our algorithms and then come up with a new labels like fictional books intended for a target audience of 20 to 40, fictional books intended for audience 40 to 60. So these are actually new clusters or new groups which are automatically identified by the algorithms. So this comes under unsupervised learning. So modeling, what are the actual major activities involved in modeling? The modeling actually is selecting a modeling technique and then making specific assumptions about the data and then generating the test design. Test design meaning by describing the intended plan for training, testing and evaluating the models. A primary component of the plan is determining how to divide the available data set into training, testing, and validation data sets. Then build the model and run the modeling tool on the prepared dataset to create one or more models, and then list the parameters and their chosen values along with the rationale for the choice of the parameter settings. So during modeling we do a lot of parameters refining, parameter tuning, parameter definition, and then their values, and also why we are setting those parameters. Then build a model and describe the resulting models, report on the interpretation of the models, and document any difficulties encountered with their meanings. Interpret and access the models according to domain knowledge, data mining success criteria, and desired test design. And revise these parameter settings according to the model assessment. Actually, if you can see here, every step involves documentation. So because we want to build the models that can be reproduced easily or can be modified or customized for different context or different problem statements later in the future. So documenting all the procedures that we are or activities that we are doing during every stage of data mining is very important, including the modeling stage. So actually, I will explain in detail about the activities defined in modeling. So these are some of the data mining approaches. Data retained means in this data mining approach we can see data retained and data distilled. Data retained is we already have cube data, then we can analyze that cube data using k nearest neighbor clustering algorithms, case based reasoning algorithms. And data distilled is which may not be intended for specific use, but we need to come up and explore apply data mining and then gain knowledge. So that can be further divided into logical, cross-tabulational, and equational. We can apply rules and decision trees on logical data that we gather. Suppose, and then rules also have induction and genetic algorithms. Decision trees are based on the statistical models, and cross-tabulation we are not going to cover in this, but equational means neural nets, and statistics we can apply data. So actually, these are the different data mining approaches. So prediction of models for predicting and classifying, suppose. Then we can use regression algorithms. That is, whenever we want to predict a numeric outcome such as the number of sales, suppose, then we can use these regression algorithms. So neural networks, rule induction, OLS regression, that is CART, can be part of regression algorithms. Classification algorithm which predict symbolic outcome or categories. We can use a chi-squared automatic interaction detection, discriminant analysis, or logistic regressions. These come under prediction models for predicting and classifying. Usually, the majority of the models are for descriptive models as well, for grouping, clustering, and finding associations for market basket analysis. So clustering and grouping algorithms are k-means clustering, Kohanen clustering, but k-means clustering is quite popular. Association algorithms, a priori and GRI, they actually are used for finding association between different data points and then grouping the items. We will see the example in future slides. So usually descriptive models are analyzing for the existing data and grouping them or classifying them, trying to find the relationship between each of the data entities. So these are under grouping and finding association models. So these are data mining algorithms. Example, market basket analysis, memory-based reasoning, cluster detection, link analysis, decision trees, and rule induction algorithms, neural networks, genetic algorithms. These are quite popular ones. So I will try to describe briefly here the different data mining algorithms. We may go in detail in future sessions. So market basket analysis. This is type of a clustering algorithm used to predict purchase patterns. Actually, it involves identifying the products likely to be purchased in conjunction with other products. This is just an example. Suppose there's a very popular story that people or men who go to groceries will buy, who buys diapers on a Friday nights also will buy beer. So this is a very interesting market basket analysis. So usually the grocery shop may keep diapers as well as beer together so that the sales are higher. So this is an example of a market basket analysis. Apologies. Then memory-based reasoning. So we can use known instances of a model to make predictions about unknown instances. So for example, we can use known instances of sales of a particular products in last 12 months, and then we can do a sales forecasting for next month. Or we can do fraud detection by working from known cases to predict new cases. Fraud detection in case of credit card or claims, where we know from the past behavior or past instances of the different data or entities to detect frauds in the upcoming transactions. Detection. These are like a grouping, finds the data records that are similar to each other. The k nearest neighbor, where k represents the mathematical distance to the nearest similar record, is an example of one of the clustering algorithms. Suppose we want to cluster certain types of books in a library, then we can use k nearest neighbors clustering, where we can group them according to the target readers, or according to the subject of the books, or according to the number of sales of the books, or number of lending of the books in the library. So different parameters can be used. Link analysis. Actually, link analysis is identifying the relationship between different records to discover patterns. Link analysis can provide the basis for various affinity in marketing programs. Similar to Markov transition analysis methods, link analysis also use probabilities that are calculated for each observed transition. The major example of link analysis would be similar to the association rules. How two or more products sold in a grocery are linked. So we can form a link diagram, link analysis flow diagram, and then try to analyze, okay, certain products sold actually are linked together or tightly coupled than compared to other products. Suppose, for example, the fruits and vegetables section is closely tied with milk section. So yeah, this can be analyzed via link analysis. I will show in the example in the upcoming session. Decision trees and rule induction algorithms. So one of the popular data mining technique is decision trees. So these algorithms actually form a tree-like structure where we can, in the form of rules, as you can see here, the order taking, suppose order the credit ranking example, there are two categories, good and bad. So suppose if the decision tree, right, if the income is less than 40k suppose, and he's doing in a job in the same job greater than 5 years, then it's a good risk. Suppose the job is less than, then it may be a bad risk. If the income is greater than 40k, high debit, then it's a bad risk. And then if the income is greater than 40k of the person, but he's having a low debit, he or she is having a low debit, then it's a good risk. So this is form of a decision. Actually, this produces the decision trees. So actually, we can also decide if this generated decision tree, we can convert it into rule set actually. So rule 1 for good risk, if income is greater than 40k, then it's a good risk. If suppose the income is not 40k but he is on low debt, then it's a good risk. Rule 2, if income is greater than 40k and the job is greater than 5 years, then it's a good risk. So this kind of rule set is also form of rule induction. So in this example, we can say here, right, uh, credit ranking 1 is default. This is the high level tree, and then we can see here there are good and bad categories defined, and the percentage and the number of people. 52.01% of bad categories and number of people is 168, and good category is 47.99, number of people is 155. So then we can divide it into two leaves, or like weekly pay and monthly salary. Again, weekly pay, we can again divide it into age category, and we can use p-value and chi-square value statistical terms, and then we can convert it into young and old. And again, monthly salary also we can again convert it into young people and old people, or middle-aged people and old people. Then again, the young people can be categorized into social class, management, or clerical, or professional. So we can form a decision like this, decision trees like this. It looks like a tree structure. So we can decide at each stage, giving a parameter, a condition, and then break it into a tree structure. And then similar to the income job, we can apply different rules or form a rule set to come up or to deduce or to find patterns, or to learn some of the results from the data analysis. Next is a priori algorithms. Actually, a priori algorithms rely on seeking association rules in the dataset. This is a classic example of market basket analysis. So as you can see in the a priori algorithm, this is one of the results in a food section of a grocery and food chain. So we can see frozen meal here is associated with fish, and fish is strongly associated with fruit veg, and wine is strongly associated with confection, and beer is strongly associated with frozen meal. So actually the visualization of the a priori algorithm is similar to link analysis, as we saw here, link analysis. Actually, the a priori algorithm also depends on the association rules. So the visualization part, the output, is similar to link analysis. So a priori algorithms, using a priori algorithm, we can actually try to use in use cases cross-sell and upscale. Suppose if you want to sell a customer who is buying a fish, there is a high chance that he may also buy fruit veggie. Suppose a customer is buying beer, there may be a chance that he may also buy a frozen meal. According to after looking at this example, so this is kind of association. We are trying to associate one product with another product in the data set. So this a priori algorithm is quite popular in associations. So usually used in cross-sell and upsell models. So we are trying to sell a product based on the purchase behavior of other products, and then we are trying to sell the number of volume, that is upsell. Next is quite more popular is neural networks. Actually, neural networks, they try to model neurons in the brain. They learn from a training set, and then that can be used to detect patterns inherent in that training set with the test data. Neural networks are useful or effective when the data is shapeless and lacking any apparent patterns. But usually the neural networks are black box based, meaning there will be hidden layers where the computation happens, and then we see the output. So we can provide the input, the out, and configure the hidden layers, and then we can see only the output. So it becomes sometimes it becomes hard to understand the results, difficult interpretation, and tends to overfit the data. Overfit the data means when we try to test this neural network on a certain training set, the performance will be very good, highly accurate. But the moment we put it on to a testing set on a real world data, the performance may not be as accurate or as accurate as the test training, or as effective as training set. So neural networks perform very good on training set, but it may not be, when we deploy that model into the real world scenario, it may not perform as effective as it was performing on the training set. So we tend to say this neural networks as overfit, meaning the network is tuned or refined for that particular training set, but it may not be suitable for the actual world or testing data set. The neural network works with all the data types, but it requires a lot of time for data preparation and extensive amount of training time. Here you can see a sample neural network which has a set of input layers and a set of hidden layers to be configured, and then there's the output layer. Let's see an example of neural networks. So we want to predict number of sandwiches sold in a daily sandwich shop based on whether it's raining on that day, whether it's a payday for our workers, or whether it's Monday or Tuesday or Wednesday, Thursday or Friday, which day of the week, and the temperature of the temperature of on that day, particular day, and then some bias. This is a personal bias. So as you can see, the payday, raining payday in the area, temperature Fahrenheit, the week of the day, the scale temperature, all act as input parameters to this neural network. And then these are the hidden layers where we perform a lot of computing as a black box, and then we get to see the value, the output, the sandwiches sold. So this is a classic example of neural network where the inputs are normalized and then fed into a hidden layer of the neural network, and then we can see the output, which are predict the output, which are sandwiches sold. Actually, these hidden layers, in its simplest neural network, there is no feedback, but these hidden layers can be multiple layers also, and also the we can use output of each layer to act as a feedback. That is recurring neural network. And there are different kinds of neural networks actually. We are going to see that in detail later sessions. So once, okay, now we are into next evaluation stage, meaning we completed the data modeling stage. Now we are into evaluation. As you can see, once we evaluate, we can go back to the business understanding stage if we are not satisfied with the results. So yeah, let's see the evaluation stage. This is a revision sub-step as a way to fine-tune the solution offered by the process. Checking if the process makes sense in a sustainable and scalable fashion is done by going back to the business understanding roots, meaning whether the models that we have built are performing well, or the results that we have obtained is in accordance with the business goals. We can always check back and go back. But as always, at each stage of this CRISP-DM, we compile a report, which is very important. So in the model evaluation, we see how well the performance is on the test data. After we do performance, or after we deploy or run the model against the training data, we test how it will performed into a test data. Suppose we want to analyze stock data. We have applied multiple techniques. This is 2020, so we have applied stock data results till 2013 to 2017, so 5 years of data, and then that is the training data. We have trained the models using the data set, stock data set, that we have from the year 2013 to 2017, and we are testing the same for the year 2018 and 2019. So if there is not much difference in the training results and the testing data results, then we are sure that the model is consistent. Then we can apply in real world, that is 2020. So we also analyze different error rates and also analyze how much accuracy is the models are providing the results, and then we interpret and then document it again. Once we are okay with the evaluation, then we need to deploy it. So usually the deployment stage caters the deployment aspect. So we plan monitoring and maintenance by summarizing the monitoring maintenance strategy, including the necessary steps and how to perform them. Whether it will be a real-time deployment, whether it will be a daily deployment, or whether it will be a production environment deployment or a UAT deployment, different deployment strategy will be discussed. And then we produce a final report which will include all the various previous deliverables, summarizing and organizing the results, and then we see the review and then we present it to the management of overall steps that will be involved. So usually the deployment is the final step, as we can see. So we determine how the results will need to be utilized, who needs to use them, and how often do they need to be using them. And also we score a database, we come up and analyze which database will be suitable, and whether we can these results can be used as business rules, and interactive scoring can be done online as well. So all these strategies will be compiled and reported in a deployment report. So this is a summary of CRISPDM so far we discussed. Yeah, we know that we discussed a lot of things, but this is since it's an overview, I have not gone in detail for each stage, but I will try to cover individual aspect briefly so that we can discuss in depth in upcoming sessions. So just to summarize the summary of CRISPDM. So first you start with business understanding, that is start with the important step of determining business objectives, the background, business objectives, business success criteria, situation assessment, where inventory of resources, requirements, assumptions and constraints, the risk and contingencies involved, terminologies to be referenced by all the stakeholders, and cost and benefits. And we determine the data mining goal, and then data mining success criteria as well, and then we produce the project plan and initial assessment of tools and techniques that may be required for this whole project. So these all things activities are under business understanding. Once the business understanding is we are comfortable with sufficient data in the business understanding, then we go to data understanding. So as part of the data understanding, we do collect initial data and then we report it. Then we describe what kind of data is there. Then we describe in the data description report, and then we explore the data, and then that is documented in data exploration report. Then we verify data quality, how much missing data is there, what kind of data has been collected. So then we represent that in a data quality report. So then comes the data preparation, where we prepare different data set and also we document it in the data set description. We select the data and we document why we have selected certain data and why we have excluded certain data. Then we clean the data, then we document it in data cleaning report, construct the data required for modeling and merge the data, and then we come up with the definitive derivatives of new data or data transformation which may be required by the modeling stage. So we reformat the data. But the important thing is document every activity that we have been doing for reproducibility in the future. Once the data preparation is done, most of the job is done actually as part of data preparation. Then we apply data modeling. So we use appropriate modeling technique, making some assumptions. Then we test. Actually, we split the data into training and testing data, and then train the data. Using the training data, we train the model, and then we assess the model, and then we apply that model into test data, and then we do evaluation of the results, that is assessment of data meaning results with respect to business criteria in the first step, and the approved models, and all the review of the process that we have been doing over the period of this project, and determine the list of possible actions and decisions, including the deployment plan. So the deployment plan contains actual deployment plan, whether it's monthly, daily, weekly, what are the targeted audience of the system, monitoring and maintenance plan, and then the final report, final presentation to the management, and a review of the project report. Build with the review project report, like the experience documentation. So these are the overall higher level steps involved in typical data mining crisp methodology. So the next sessions, I would like to try and explore CRISP DM walkthrough with an example project. Currently, I know that currently I have covered with the mostly theoretical approach. Maybe it would be interesting to cover an end-to-end CRISP DM. Maybe it's interesting to cover take a sample project and walk through different stage of CRISP DM for that project, so that we have a better understanding of CRISP DM. And then during that we can also discuss the modeling techniques in detail, and also the visualization techniques, the do's and don't, maybe a separate session for that. So we covered overview of CRISP DM. Just to summarize again, so we are here at all the after the data mining, we infer and evaluate pattern and results, and then we represent the data in a way that is interpretable by the end users, and then also it can be integrated to the and automated to the testing systems and information technology systems, so that the results can be useful. So this is the overall knowledge discovery steps, including the CRISP DM methodology. So if you have any feedback and queries, kindly contact me at the given LinkedIn or Gmail ID. And yeah, thank you NUS BACT and its members for allowing me to present this session. Looking forward for future sessions as well. Thank you. Have a nice day.